Today I'm going to be talking about the partial quotient strategy for division. This is a 4th grade standard. It also is a 5th grade standard. So I'll show you what partial quotients are and why we do that versus the standard algorithm, which we also call long division. So just so you are aware, long division is not a standard until 6th grade. So in 4th and 5th grade, students are going to be asked to use the partial quotient strategy. In 4th grade, they're going to be using whole numbers, and then in 5th grade, I will do an extra video where students are required to do decimals. Okay, so let's go ahead and get started. So what partial quotients does is it talks about the place value relationship of the number that you are dividing by with the number that you are dividing into smaller groups. So if we looked at this, we would say 464 divided by 3. So if we were to split 464 up into 3 even groups, what would be the answer? Okay, so how we set it up with partial quotients is we're going to use a place value chart, okay? So in 464, we have hundreds, tens, and ones. So that's the first thing we're going to do is we're going to be drawing rectangles for hundreds, tens, and ones. And students are familiar with place value charts as we've talked about them a lot in the classroom. So we're gonna label this hundreds, tens, and ones, okay? So what we're gonna do now is, just like we did partial products with multiplication, we need to separate this number, okay, into its place value. So we have hundreds, we have 400, tens, we have 60, ones, we have 4. So we're decomposing the number 464 into the place value chart. What we're doing is we are dividing by 3. Oops, so we're gonna put dividing by 3 over here. So the first thing we need to do is figure out how many hundreds, groups of hundreds, or 300, can we subtract off of 400. So we're looking for groups of 300, okay? So what we're looking at is if we want to make 300 out of 3, we're going to be taking out 100, right? Because 100 times 3 is 300. Then we're going to subtract, okay? Now we have 100 here. We can't multiply 3 by any other hundreds because that would be more than 100. So what we're going to do is move 100 over here to our tens column. So now we have 160. So now we're going to be thinking, can I take out 10 groups of 3, 20 groups of 3, 30 groups of 3, 40 groups of 3, 50 groups of 3 to get close enough to 160? Well, because of the powers of 10 rule, we know that 3 times 5 is 15, and we can add a 0 because it's tens position, right? So 3 times 50, or 50 times 3, would be 150, and we're going to subtract again. Left over is 10. There's no tens that we could multiply by 3, so even 10 times 3 is 30, which is too many. We only have 10 left over. So now we're going to bring our 10 over to our ones column. Now we need to figure out and use our multiplication facts for how many times can 3 go into the number 14. So this is where you might rote count by 3s, okay? Or you could use your multiplication chart to figure out what number you can multiply 3 to get closer enough to 14, okay? So let's rote count 3, 6, 9, 12. If we went to 15, that would be too many because we only have 14 left. So what we're going to do is we're going to take out 4 groups of 3, which is 12, and there's going to be 2 left over. There's nothing that you can multiply by 3 to get to the answer of 2. So that means 2 is our remainder. Now what we do, we have these up here which are called the partial quotients. Okay, we add those back together just like we did in the partial product strategy of multiplication. So we have 154, remainder 2. Now, let's see if you want to check your answer. So what we have to do is we have to multiply 154 times 3 because multiplication and division are the inverse operations of each other. They are the opposites. So if we're going to check our answer, we multiply 154 times 3 and then you add whatever is left over as the remainder. So let's go ahead and do that. 154 times 3. This is our partial product strategy. So 3 times 100 is 300. 3 times 50 is 150. 3 times 4 is 12. We add our partial products together to get 462. And then we need to add that remainder 2 that's left over. The remainder is what is left over. It does not have a nice even group of 3. So the answer is 464. When your answer down here after you check it matches the number up here, your answer is correct. Now let's go to the second one. We have 3,269 divided by 3. The 4th grade standard is that students can divide 3 and 4 digit numbers by a 1-digit divisor. Okay, so they're only going to see 3-digit numbers and 4-digit numbers. Okay, so we're going to break it apart and decompose it into a place value chart, but this one also has thousands this time. So what we're going to do is we're going to do our place value chart, but we are going to do 4 columns this time for thousands, hundreds, tens, and ones. So here's our thousands, our hundreds, our tens, and our ones. Okay, so we need to decompose or break that apart. So we have 3,000 in the thousands column, 200 in the hundreds column, 60 in the tens column, and 9 in the ones column. Okay, we are dividing by, let's divide by 2 instead. So we're going to divide this number by 2 or cut it in half. Okay, so now we need to figure out, can 1,000 groups of 2 come out of or be subtracted from 3,000? Yes, that would be 2,000. So we're going to have 1,000 groups of 2. You multiply those together and subtract. Okay, there's 1,000 left over. We can't multiply 2 by any other thousands to get only 1,000. Okay, so we're going to move that 1,000 now over to our hundreds chart. So now we need to figure out how many hundreds, 100, 200, 300 groups of 2 can come out of 1,200. Knowing our powers of 10 rule, 2 times 6 is equal to 12, and we add 2 zeros because it is the hundreds chart. So we add our 2 zeros and we subtract. There's nothing left over here, so we don't have to bring anything over to our tens column. Now we need to figure out how many tens, 10, 20, 30, 40, 50, 60, times 2, how many groups of 2 can be subtracted from 60, okay? We know, because of the powers of 10 rule, 2 times 3 is equal to 6, and then we add a 0 because it's in the tens column, and we're going to subtract again. There's nothing left over to bring to the ones column. So now we have to figure out, with our multiplication facts, how many times can 2 go into 9? 2 can go into 9 4 times. We're going to subtract our 8 because 4 times 2 is 8. There is 1 left over. There's nothing that we could multiply by 2 to get to 1, so that is our remainder. We need to add our partial quotients together. So your answer, your quotient, is 1,634, remainder 1. Okay, and I'm showing students that the R goes in a circle right after the answer. Again, if we wanted to check our answer, we could. So we'll decompose 1,634 times 2, because that's what we were dividing by. 2 times 1,000 is 2,000. 2 times 600 is 1,200. 2 times 30 is 60. 2 times 4 is 8. Okay, so then we add those together. The answer is 3,268. Don't forget about your remainder. You need to add your remainder back. Okay, so the answer is 3,269 total. That number matches the number at the top. So again, with the place value understanding, students know already how to decompose numbers because we've been practicing that all year long. They've actually been practicing decomposing numbers since kindergarten, and in kinder they only did tens and ones. Okay, in second grade and first grade, they did hundreds, tens, and ones. And in third grade, they got up to thousands. So they would practice those place value strategies of decomposing the numbers over and over. And we actually started the year fourth grade with that, okay? Please let me know if you have any questions.